Okay, we're here with a video to talk about finding area under curves. Remember, if we're looking for area, we're going to be integrating. We're always integrating the upper curve minus the lower curve. If you only have one curve, dump the low. You can only work with the one. And we'll always be looking for a upper limit of integration to a lower unit of integration. As a matter of fact, before we work on a couple of select problems, please remember you have to be able to state the fundamental theorem of calculus, which says if g of x equals the integral of f of x dx, then the integral from a to b of f of x dx equals g of b minus g of a, meaning the integral of the upper bound minus the integral of the lower bound. So when we go to work on problems, let's look at the hardest version first. Well, actually the hardest, it's the most work. That's when you get two functions and they don't tell you where to start or where to finish. They'll start off with an equation like this. So they want me to find the area between those two curves. Notice that I wasn't given any limits of integration, any upper bound and lower bound. I have to find those by setting these two equations equal to each other and solving them. So I'll get x squared plus 4x minus 2 equals negative 2x minus 10. It's a quadratic, so I'm going to get everything on one side. Plus 2x plus 10. Crisscross applesauce. Divide. And we get x squared plus 6x plus 8 equals 0. Remember, you only do this procedure when you don't know where to start and where to go. That's why I'm setting them equal. It's going to give me their intersection points. So it's going to be x plus 4, x plus 2, and that means that this is x plus 4 equals 0. Subtract 4. X plus 2 equals 0. Subtract 2. X equals negative 2. So that means my limits of integration for this function are going to be from negative 4 to negative 2. Now Will was just worried, why did I write the smaller number up top? I didn't. It's in the negative direction. But put the numbers down the wrong spot, you'll still get the right answer. As a matter of fact, I looked at what the graph of this function looks like, and it looks like kind of like that. And my limits matched exactly those locations. So now that we know where our upper bound and lower bound is, we just got to figure out which curve is on top of the other. There's two ways. The easiest way that usually works is you take a look at the shapes of the graphs. The first curve is a quadratic and a happy one. The second one is a line going down. So I would assume right off the bat that the upper curve is the line and the lower curve is the equation over here, lower curve. So I would write them on in and put upper minus lower, negative 2x minus 10, minus lower, x squared plus 4x minus 2 dx. If you're not sure about that, you can always pick a number in your interval. My interval ranges from negative 2, to negative 4, or negative 2. I'm going to pick a number in between there. I'm going to choose negative 3. If I put them on in the equation, I'll know which number has a higher value, so I'll know who's the upper curve. So I'll fit in negative 3, so that becomes 9. 4 times negative 3 is negative 12, minus 2, which is negative 5. And this function is going to be negative 2 times negative 3, which is 6, minus 10, which is negative 4. This is the higher value. It's up farther on the number line, so it was the upper curve to begin with. So you can integrate this in one of two ways. You can simplify the problem and then integrate, or you can integrate right from the parts you have right here. Most of you seem to want to do this without simplifying, so I will do that as well. I'm going to integrate this function, and I get negative. That's the integral of that statement right there from negative 4 to negative 2. I thought you had me there for a second, but you didn't. Negative 4 to negative 2. And then now I've got to fill out all the way upper minus lower. So first I put the negative 2 in for everything, and then I'll put the -4 in for everything. I'll do them in two different colors. So I believe I've written that out correctly. The red is the upper bound. It's -2 filled in into every spot. And the green is the -4 filled into every spot. I can simplify farther, and you could make the squares and cubes go away. Just make sure you keep your signs accurate. So sometimes we have to find the area between curves that we can't slice along the x-axis. We have to slice them along the y-axis, and that's a little challenging to do. We don't fully visualize it well. Whenever we have things we can't put in the calculator, like this, what we're going to always do is for all the equations. So what this graph kind of looks like is like this right here. So now I can't slice along the x-axis anymore. I'd have to take my slices out along the y-axis. But that can be confusing to think about. When you can't slice along the x-axis, when you can't slice vertically, the easiest way to do it is to take your original equations and just switch all the x's with all the y's in both equations. And any x's you have turn to y's, and any y's turn to x's. I'm going to take these two equations. I'm going to say this is x equals y plus 3. And I'm going to say that this is y equals. So the reason we switch that around is it gives us the graph we want and the view that we're going to want it. So then if I had my calculator, I would graph both this function and this y is not by itself. So I can't graph it. Yes, you can. Just get the y by itself. Subtract 3 from each side. So your two equations you're graphing are. So we're going to set this one, but we're not going to evaluate it. I'm going to enter this into my calculator. So I graph this function, and now I can tell by looking at it in the x direction, the parabola is on top, the line is on the bottom, and I'm able to use my intersect tool to find that they intersect at the x values of 1 and the x value of 4. So when I set up my integral, it's going to be the integral from 1 to 4 of the first, the top function, -x squared plus 6x minus 7 minus the lower function, x minus 3 dx. I'm going to put them into my calculator right now. I'm going to pick up a calculator page. Calculator, menu, calculus, integral from 1 to 4 of 2 of x minus f of 1 of x dx. And I got the answer of 9/2. Now that number is right, that's the actual area. But remember, to get the graph to look good for me, I had to change the orientation of it, so I switched all the x's and y's. To put the right information, I don't want to say information, to put the correct terminology, that's better. Back for this new question, I'm going to switch all the x's to y's and y's to x's. 1 to 4, -y squared plus 6y minus 7 minus y minus 3 dy equals 9/2. And that's how we convert that one back. And the last piece of information you need to know is you can only integrate when the function you have is continuous. Meaning, if I wanted to find the integral of this function between -2 and 2, I can't do it because there's a hole up in the graph right here. Anywhere there's a hole, you cannot integrate over that region. You have to move to a different spot. And one last piece of info that I didn't talk about in class, but I'm going to talk about in the video, is the following. Let's say this function is f of x. And this function is g of x. And I ask you to find the area trapped between the two curves. Well, there's 3 regions where the area is trapped. Here, here, and here. I can't integrate this function all the way from 2 to 16 at one time, because in some spots one graph is on top, the red graph is on top here, and in other spots the blue graph is on top. So the solution to that type of problem is just to do it in parts and do upper minus lower. So to find all the area trapped here, I'm going to do the integral from 2 to 6 of the upper curve is f of x minus g of x dx. And for this next interval, it's going to be the integral from 6 to 8 of g of x minus f of x dx, because this one, the g is on the top. And for the third one, it will be the integral from 12 to 16 of f of x minus g of x dx. And then to find what the area is of all three combined, I would just add those three separate things together. Okay, there's the info you need for tomorrow. Nicolette's coming in for help, so I gotta go. Bye-bye.
Good luck.